Good morning. Today we are going to see the topic called frequency distribution. It is a statistical tool when we need to find out how varied the pattern of the data set. So to identify that, we can go for frequency distribution. Frequency, we all know that how much time it gets repeated. So here a frequency distribution is a tool which helps to organize the data for reaching meaningful conclusions. It means that how much the data pattern has been achieved. It can be identified by using frequency distribution concept. It shows the number of occurrences of the possible result, how much times it have been carried out. So the frequency distribution can be represented in any one of the forms. Usually the graphical representation is used to find out the frequency pattern. So here histogram, bar graph, frequency polygon and pie chart are various graphical representations which is used to describe the frequency pattern. So here histogram, it suits only for continuous set of data. In case of bar graph, we can go for discrete data. Frequency polygon, we could consider comparison of various data sets. So here we are considering the midpoints of the class frequencies. Then pie chart, we all know that circular graph where each section will belongs to each and every division. So it shows the data proportion pie chart. So these are the various representation of frequency distribution. Then we will move for the types of frequency distribution. Here grouped frequency, ungrouped frequency, relative frequency and cumulative frequency distribution. So these are the four different types. Let us see in detail. In case of grouped frequency distribution, here we will collect all the observations and we will group all the observations into certain group called class intervals. So we could make class interval and we could find the frequency of how much values occurred in that class interval. So here it is an example. This kind of grouped frequency distribution is suitable for larger data sets. So here there are set of data and we could split all these data into 5 different groups, 5 different class intervals, and we could find that between the class interval 10 to 20, that is including 10 and excluding 20, we are having 5 observations. And then likewise we should follow for all the class intervals. So this is a grouped frequency distribution. The next ungrouped frequency distribution, it is suitable only for smaller data set because we are not grouping. We are taking each and every value as a discrete value and we are finding the frequency of it. So it will be useful only when the same value gets repeated for more number of times and there are no much possible values. So in that case we should go for ungrouped frequency distribution. Each and every value is counted individually. Here among these data set we are counting 10 is counted in the 10 is having the count of 4, 15 is having the count of 3, 20 is having the count of 2. Likewise we could select each and every value and we could find the count. The next is relative frequency distribution. In this distribution, we will have one formula called frequency of event divided by total number of events. It is like finding a proportion, that is among total distribution, how much this value gets distributed. Like this, we could find the proportion of the total class, proportion of a particular class among the total class. So it is basically used for comparing data sets, that is how much proportion this data is getting distributed and how much proportion the another data is getting distributed. So next relative frequency distribution example. Here we are taking the range of values and we are finding the frequency. Among this we are taking out the proportion. So for proportion, the total number of events occurred will be calculated like if we are having so much of class intervals, we could find the total number of values, that is we are counting the frequency and we are getting the total as 50, so that we could divide each and every frequency by 50. We could obtain among 50 how much this class interval is getting distributed. Suppose when we are taking 5 divided by 50, we are getting 0.10, that is 10% of values are distributed among the 50. So this is the thing we could relate from the relative frequency. When we add up all, it could sum to 1. The next is cumulative frequency distribution. In the same, how we are saying cumulative means total. So likewise here also we are adding up all the frequency to form a single cumulative frequency. It could get represented in two different forms, that is less than type and more than type. In less than type we could sum all the frequencies before the current interval, but more than type we could add up all the frequencies after the interval. So these are the differences. Let us go for the example. So in case of cumulative frequency distribution, we have we have collected 25 possible observations. Then next is we could form a frequency distribution table, like we are setting up the class interval and we are finding out the frequency of it. So we should find the cumulative frequency for this table. In the time, if it is 0 to 10 runs, we are having the frequency count of 2. When we are taking 10 to 20, we should add up with the previous frequency. That is the thing. So here less than 10, less than 20, we are taking up the maximum values, and to that maximum values we are adding all the things. Less than 20 means it could cover these two classes, that is 0 to 10 and 10 to 20, so that we could add up 2 plus 2 4. Like this we could add till the last value. We are getting the total cumulative frequency as 25. In the same way we can also go for more than type. In that of more than type we could take up from the last value, last interval, more than 90, more than. So here we are considering the upper boundary values, that is less than 10, less than 20, less than 30. When we are taking for more than type, we could have more than 0, more than 10. Like this we should consider the lower boundary value. So less than type considering the upper boundary value, and more than type will consider the lower boundary value. So these are the four different types of frequency distribution. Among these we could select any one of the frequency distribution according to our application, and we could find the frequency of pattern, how much it gets distributed. That's about frequency distribution. Thank you.